Hello students, and you are welcome back to solve your physics past question class. Today we'll be looking at the aspect of capacitor in physics as we solve our questions from West African Examination Council across the year 2011 to 2012, looking at different aspects of capacitor and the questions we may come across these years. So the first question we have in today's class is from the White Past question 2011. It says a 10 microfarad capacitor is connected in series with a 5 microfarad capacitor. The combination is connected to a 12-volt battery. Calculate the total charge on the series combination. When you pay attention to this, we're told to calculate the total charge on the series combination. So the first thing we have to do is to get the equivalent capacitance of the capacitors. So to get the equivalent capacitors, we have to note what kind of connections are our capacitors connected in. So we can see from our questions that they are connected in series. So we use the formula 1 over equivalent capacitance equals to 1 over C1 plus 1 over C2 because we're given two capacitors. So the first capacitor is 10, the second capacitor is 5. So when we plug this into this formula, we have 1 over equivalent capacitance equals to 1 over 10 plus 1 over 5, which is equals to 1 plus 2 all divided by 10, using 10 as our LCM, which we further get 3 over 10. So when we cross multiply, we have equivalent capacitance to be 10 divided by 3 microfarad. So when we further divide this, we have 3.33 microfarad as our equivalent capacitance. Now that's not all. The next thing for us to do, remember from our question, is to get the total charge on the series combination. So to get the total charge on the series combination, we use the formula of the charge, quantity of charge on capacitor, which is Q equals to equivalent capacitance times voltage. From our question, we're given a voltage of 12 volts. So, and our new, or let me say, equivalent capacitance is 3.33 microfarad. So when we plug in this into our formulas, we have Q equals to 3.33 times 10 to the power minus 6 farad times 12 volts. So when we multiply this together, we have 40 times 10 to the power minus 6 coulombs. So which we can further rewrite as 40 microcoulombs as our final answer. The next question I have here today is from the White Past question 2012. It says a 4 microfarad capacitor is charged to 8 volts. Calculate the energy stored in the capacitor. To get the energy stored in the capacitor, we use the formula E equals to half CV square, where C is the capacitor or capacitance and V is the voltage. So then when we look at our question, we're given a capacitor of 4 microfarad and we're given a voltage of 8 volts. So we substitute this into our formula. We have half times 4 times 10 to the power minus 6 times 8 squared. Remember that microfarad is 10 to the power minus 6. So we can further get half times 4 times 10 to the power minus 6 times 64, because 8 squared will give you 8 times 8, that will be 64. So when we divide through by 4 and we multiply this together, we have 128 times 10 to the power minus 6 joules, which can also be written as 128 microjoules as our final answer. The third question I have here with me is from the White Past question 2013. Find the total capacitance when a 12 microfarad capacitor is connected in parallel with a 3 microfarad capacitor. So when you look at this question, we're told to find the total or equivalent capacitance. So to find the total equivalent or equivalent capacitance of this capacitor, we are to find in what connections were they connected. We can see that it is in parallel. When it comes to parallel connections of a capacitor, we know that the formula is total capacitance is equals to C1 plus C2 plus C3 plus C4 plus C plus dot 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 plus till infinity, till the total number of, or not total number of the capacitor that we might be given. But from our question, we're given just 2 capacitors, so we stick with 2. So we have total capacitance equals to C1 plus C2. The first capacitor is 12 microfarad. The second capacitor is 3 microfarad. So when we plug in this into our formula, we have total capacitance equals to 12 microfarad plus 3 microfarad. So we have 15 microfarad as our total or equivalent capacitor in these questions, which is our final answer. Then the fourth question we'll be looking at in today's class is from the year 2014. It says a 15 microfarad capacitor is connected to a 50 volts supply. What is the potential difference across the capacitor when it is fully charged? You must understand that when this battery is fully charged, the potential difference across the capacitor is equal to the supply voltage or voltage supplied. Therefore, potential difference will then be 50 volts, just as what they've been connected to in as the numbers were given in our questions. So the last question we'll be solving for today's class is from the white past question 2015. It says two capacitors, 6 microfarad and 12 microfarad, are connected to the series and charged to 20 volts. What is the voltage across each capacitor? Now here we're told to find the voltage across each capacitor. The first thing we have to do is to find the equivalent capacitance of the capacitors. So we are told that these connections were connected in series. So we use the formula of capacitors in series. So we have 1 over equivalent capacitance equals to 1 over C1 plus 1 over C2. Just that we're given two capacitors from our question. So the first capacitor is 6 and the second capacitor is 12. So we have 1 over equivalent capacitance equals to 1 over 6 plus 1 over 12, which is equals to 2 plus 1 all over 12, using 12 as our lowest common multiple. So we have 3 over 12. So when we cross multiply, we have equivalent capacitance to be 4, because 12 divided by 3 is 4. So we have 4 microfarad as our equivalent capacitance. Now, the question now still remains that we have to calculate the charge, which is Q, on each capacitor. So to calculate the charge on each capacitor, let's calculate the quantity of charge on the equivalent capacitance. So the quantity of charge on the equivalent capacitance is Q equals to CV, that is Q equals to equivalent capacitance times the voltage. So what is the equivalent capacitance? That is 4 microfarad. So we plug in this into our formula. We have Q equals to 4 times 10 to the power minus 6 farad times 20 volts. So we have 80 times 10 to the power minus 6 coulombs, so which can also be written as 80 microcoulombs as the quantity or the charge on the capacitors. Now, the question which we now need to now solve is to calculate voltage that runs across each capacitor. So we know that the first capacitor is 6 and the second capacitor is 12. So now let's calculate it. So using the formula Q equals to CV, now we have the quantity of charge on the capacitance and we have voltage that runs across each capacitor. So now we now have to find the first voltage that runs across the first capacitor, which is 6 microfarad. So we say Q equals to C1 V1. C1 there means first capacitor, while V1 there means the voltage that runs across the first capacitor. So making V1 the subject of formula to get the voltage that runs across the first capacitor. So we have V1 equals to Q divided by C1. What is our Q? Which is the quantity or the charge on the capacitance, which is given as 80 microcoulombs. So that will be 80 times 10 to the power minus 6 divided by 6 times 10 to the power minus 6. When we divide through, we have 13.33 voltage. So we have 13.33 voltage that runs across the first capacitor. Then let's find the voltage that runs across the second capacitor using the same step that we use. So V2 equals to Q all divided by C2, which is the second capacitor. So we have 80 times 10 to the power minus 6 all divided by 12 times 10 to the power minus 6. So when we divide this through, we have 6.67 voltage. So 6.67 voltage is the amount of voltage that runs across the second capacitor. And this is where we are going to stop for today's class. We hope with what we have learned, we've been able to equip and better your understanding on the concept of capacitor in West African Examination Council past questions. Thank you and bye for now.